Hi, this will be a video for the viewer, the animation viewer. Immediately we can see the animation playing and the different skeletons. Right now we have two skeletons, the bear skeletons and humanoid skeletons. And in total there will be five animations. There's a bear walking, a bear idle, and a humanoid punch, humanoid shoot, and humanoid run. And this is a precisely adjusted choreographed scene, and two humans are fighting each other. And two of the animation have different frame counts, so I offset the frame count a tiny bit and change the frame rate a tiny bit to match their action. For the red one is to demonstrate the controllability over the animated component, which I'm gonna showcase shortly. So if you press Y, it's gonna slow down the frame rate, and yeah, if you press the third time, it's gonna pause entirely because the frame rate drops to 0.0 frame per second. If you press again, it comes back to 30 frames per second. And if you slow down just slow enough, you'll be able to see the bone interpolating correctly. It's not like stepping bit by bit. So yeah, if you press T, it will change the animations. Right now it's punching, and you press T again, it's going back to the running animations. Press again. You can quick switch. So yeah, this will be a demo, and I'll be talking about the codes a bit. So for my scene to work, basically we load up from the model file, just like the regular model format. I load up from the same format, which I call the S model. And load up the skeleton. The skeleton stores information of the parents and child's relations between bones. And since I've been since this is the skeleton only loads in once in this function call. So right now I only serialize the skeleton bone relations in terms of string, which is a char array, because it's only going to run once, so it's only going to construct an array once per launch. It's not going to update during the runtime or anything. Runtime, I mean. And we have an animation from the same file, and this is three lines, basically loading up different clips. The same goes for a humanoid, just like Teddy one, which I was talking about. So during the runtime, oh no, before the runtime, so I initialize. So I have two major parts, which is the animator components, which serves as the animation controller equivalent. The actors instead is kind of like in relation to animator components, just like game objects with relationship to a graphic component. So big game object take a possession of the graphic component, and the actor take possession of the animator controller components. That's gonna curate data from here, and the actor is gonna take control of the hierarchy of game object bones, which is so like the thing for this to work is at the start the actor is gonna query the skeleton, and the skeleton is gonna create a tree, a hierarchy of game object bones that's already sorted in a tree fashion, and actor is gonna grab that control of that tree. It's not the skeleton, it's gonna grab the duplicate of the game object bones tree, and then it's gonna during runtime it's gonna query the animator for the animation data, and it's gonna update each of the game object bones accordingly. So if we go over to the animator, so what the animator does is just storing the information of frame rates and etc and the reference to animation clips. And during runtime, it's going to grab the data based on the Oh, this is the actor. Based on the bone ID and the global time and the transformation data. It's gonna pass back the data to the actor, which will update in a linear fashion. It will contains a linear array of all the bones that is controlling, and it will update the animations matrix, which is different from the world matrix we have originally. So each of the game object bone, what it's gonna have is the original the world matrix, which is inside the game objects. And for the animation bone, it has its own animator. Well, there's the animation matrix, which won't be affecting the world matrix until during the game object manager updates. So what the actor is gonna do is gonna update the animation matrix um, in however order it wants, in linear orders or whatever. And then during the game object manager updates, that one will update accordingly to the tree structures and what each of the game object bone is gonna do. During that, it will be during the game object manager update, which is a tree hierarchy update. It's gonna firstly the parents node is gonna update first. And it's gonna multiply the animation matrix upon that parents matrix. Thus, the entire thing will be computed properly. And yeah, that's be the the viewer parts, and each of the actor has its own animator components for its control. And yeah, that's be it. Thanks for watching.